Surface area is the total area of the faces of a three-dimensional figure. Because three-dimensional objects come in all shapes and sizes, there are a number of different formulas to assist in calculating surface areas of different objects. A prism is a common three-dimensional object that has a number of flat faces. The most common are triangular and rectangular prisms. Every prism has sides that are designated as the base. On a triangular prism, the bases are triangles. On a rectangular prism, the bases are rectangles. Calculating the area of a prism is a matter of multiplying the area of the base by 2, since each prism has two base sides, and then finding the area of the lateral faces between them. Area of the lateral sides could be calculated in two ways. First, you could calculate the area of each side using length times width and then add them together. But this is not the best way. A better way to calculate this is to do it all at once using the perimeter of the base. Adding up the perimeter of the base is the same as adding all of the widths of the lateral faces. Then multiply the perimeter of the base by the height, and this is the surface area of the lateral faces. You could also visualize this by unfolding the prism and looking at all of the faces in 2 dimensions. This is called a net. A prism net is a layout of the prism's faces that allows you to see how the area of the faces relate to each other. As you can see, the sum of the base's perimeter, B1 plus B2 plus B1 plus B2, is the width of the lateral faces. Multiplying the sum by the height will give you the area of the lateral faces. The common formula for finding the surface area of a prism is 2 times the area of a base plus the perimeter of the base times the height. B is the area of a base, P is the perimeter of the base, and H is the height. For example, the dimensions of a rectangular prism with a 3x5 base and a height of 10 can be entered into the formula. It would simplify to 190 units squared. The surface area of a cylinder follows the same principle as you can see by the net. To find the total surface area, you take 2 times the area of the base plus the perimeter of the base times the height. The formula for a circle's area is pi r squared, and the perimeter of the base would be the circumference of the circle, which is represented by 2 pi r. If we substitute these into the formula, we are given S equals 2 times pi r squared plus 2 pi r times h as a base formula for solving the surface area of a cylinder. If this cylinder had a base with a radius of 5 and a height of 10, the solution would simplify as shown to about 471 units squared. The surface area of a pyramid is found using a formula that uses the base area, base perimeter, and slant height. The slant height is the distance measured straight up the middle of a slanted face of the pyramid from the base to the apex. The formula for a pyramid is S equals B plus 1/2 PL, in which B is the area of the base, P is the base perimeter, and L is the slant height. The net of a pyramid can illustrate why this formula works. Base perimeter times the slant height will give you the area of the shaded region, which can also be viewed as 4 congruent right triangles for each face. 1/2 of their total area will equal the area of the pyramid faces. Solving surface area for a pyramid with a base side length of 5 and slant height of 7 would be solved using the formula. Simplified, this pyramid would have a surface area of 95 units squared. A cone is similar to a pyramid. Surface area is found by adding the area of the base, pi r squared, to pi rl, in which L is the slant height. The net of a cone shows the shape of the areas that are measured. For a cone with a slant height of 8 and the radius of the base of 5, the formula would appear as S equals pi times 5 squared plus pi times 5 times 8. This would simplify to 65 pi, or about 204 units squared. The surface area of a sphere measures only one face. The formula is 4 times pi r squared. However, the measurement for the radius must be taken from the exact center of the sphere. A sphere can be sliced a number of ways that will yield two parts that are not equal hemispheres. In order to use the proper radius, the radius must be taken from a great circle of the sphere. A sphere and a great circle of the sphere will share the same center point, and if a sphere were sliced directly along a great circle, two equal hemispheres would be created. If a ball had a diameter of 22 centimeters, you could calculate the surface area by taking the radius, which would be 11 centimeters. The solution here would be about 1,520 centimeters squared. Each shape has its own formula for surface area, but the concept is the same, adding the surface area of bases to that of lateral surfaces. If you hit a stumbling block, nets can be extremely helpful and can help you piece together the proper answer.